Good morning, students. Today I am going to give a lecture on solid fuels and analysis of coal. This topic comes under fuels and combustion or energy resources. So, main source of solid fuels, naturally abundant solid fuels, wood. So, this wood undergoes qualification in its crust in absence of air, in absence of oxygen. So, first stage of qualification is called peat. Second stage of qualification is called lignite. Third stage of qualification is called bituminous coal. Fourth stage of qualification is called anthracite. So these are the solid fuels naturally abundant. So wood content of this process of conversion of wood to anthracite is called qualification. So solid fuels. Naturally abundant solid fuels are wood. In its crust, in soil, wood slowly converts into peat. The first stage of converts into coal. The process is called qualification. The first stage of qualification is called peat. Second stage of qualification is called lignite. Third stage of qualification is called bituminous coal. Fourth stage of qualification is called anthracite. Right. So this carbon content in the peat about 57% carbon percentage. Next, this lignite contains about 67%, and this bituminous coal contains about 88%. This anthracite up to 96%. Right. So as a moisture content decreases, effective calorie also increases, carbon content also increases, right? Percentage of moisture decreases from 1 to 5. Carbon content increases 57, 67 up to 88%, up to 88%, up to 96%. So as a carbon is the main contributor during the process of combustion in giving latent heat content. Therefore, so carbon is a main contributor. As a carbon content in the coal increases, its effective calorific value also increases, and the moisture content from wood to anthracite decreases. Right. So other impurities also decreases. Other impurities also decreases from 1 to 5. So anthracite is high content of carbon. The calorific value is very high. So calorific value based on carbon content increases from 1 to 5, from peat to anthracite. This high anthracite, in last stage of qualification formed during the process of anaerobic decomposition, this anthracite contains up to 96% of carbon. We use anthracite for manufacture of coke. We get coke from this. So almost 99% to 100% of carbon. This coke contains 99 to 100%, up to 100%, above 99%. So coke is very, very essential solid fuel in metallurgical industries for manufacture of alloys. So where temperature we need to maintain about 2000 degrees centigrade for making of alloys in the furnace. So to maintain temperature in the furnace of metallurgical industry, we use coke only. Main source of coke we get coke from anthracite, right? So next topic in this solid fuels and combustion, analysis of coal. Analysis of coal. Analysis of coal, we have two methods. One, proximate analysis. Proximate analysis. Two, ultimate analysis. Ultimate analysis. Right? Analyzing the impurities, carbon, hydrogen, impurities, moisture, volatile matter, oxygen present in the coal, determining accurately impurities and main components like carbon, hydrogen in the coal, known as analysis. Two methods we follow analyzing the coal: proximate analysis, ultimate analysis. So proximate analysis, first one, proximate analysis. Proximate analysis. So with this method we can analyze moisture, percentage of moisture, percentage of volatile matter, and percentage of ash and percentage of carbon. These are the components, impurities, moisture, volatile matter and ash, and carbon, main contributor, carbon. We analyze using this method, proximate analysis. So brief sequence of steps involved in every component analysis. First one, moisture analysis, percentage of moisture, right? So just you need to write point wise, no need to go through in detail, just sequence of steps involved in the laboratory, that will be sufficient, right? Percentage of moisture, we can analyze very easy. You take 1 gram of coal in a crucible, 1 gram of coal in a crucible, 1 gram initial weight of coal taken for analysis, only 1 gram every time. Any analysis, there is approximate or ultimate also, any analysis, we need to take only 1 gram of coal, take it in a crucible. Next, weighing, right? Let weight be the double 1 grams. Bottle, crucible plus 1 gram coal. 1 gram coal. Weight be the double 1 grams. So we are discussing theory class. So we need to give some value. If we are in the lab, it would be fine. We get some value. Okay. And let double 1 be the weight of bottle, weight of crucible along with the 1 gram of coal. Now, next, keep it in desiccator. Keep it in oven, hot air oven, electric hot air oven for heating. So we need to heat inside temperature maintained in oven about 110 degrees centigrade just for 5 minutes. 5 minutes. Take 1 gram of coal in a crucible. Weight, let double 1 be the weight of bottle along with the coal. Keep it in electric hot air oven. Heat it to 110 degrees centigrade, where in oven temperature maintained up to 110 degrees centigrade. 110 degrees centigrade. Heat it for 5 minutes. 5 minutes. So whatever moisture is there in the coal evaporates. that will get evaporated. So after this, we need to weigh. Before weighing, we cannot weigh it in hot condition. Cool it. Next, cooling. Then cool it in desiccator. After cooling, desiccator. After cooling, again determine the weight. Determine the weight. Let weight be the 2 grams. So weight of moisture, initial weight of moisture is called weight of bottle along with this is 1. Well, weight of bottle along with coal is called 1. After removing moisture, after keeping it in oven, heat it to 100 degrees centigrade for 5 minutes. Removal of moisture takes place here, minus moisture. So then cool it in desiccator. Determine the weight. Let 2 be the weight of bottle, crucible, possible. So weight of moisture is equal 1 minus 2 grams. Calculate percentage. Initial weight coal take is 1 gram. 1 gram coal contains how much? 1 minus 2 grams. 100 contains how much? Percentage of moisture is equal to 100 into 1 minus 2 by 1 gram of coal. 1 gram of coal that taken for analysis. So very easy. There are simple steps involved. Next, volatile matter. Percentage of volatile matter. Continue the experiment. Don't take separate sample for this. Again, if you take separate sample, again we have to remove moisture. So just continuance of previous one. Take same sample. That weight of that sample is 2 grams. After removing moisture, continuance of previous. And after removing moisture, you continue the same sample with same sample. It does not contain moisture, right? If you take separate sample, again we have to remove moisture. So you take this only. Weight of that is 2 grams, right? So you take this crucible containing this. Weight of this is 2 grams. After removing moisture, crucible plus sample, remaining sample. After removing moisture, this does not contain moisture. No moisture, without moisture. So we are not taking separate sample. Just to continue the previous one, same sample. So then just cover it with a lid. Cover it with a lid. Next, determine the weight. Let weight be the 3 grams. After this, place it in furnace. Then heat it to 940 degrees centigrade. Just for 5 minutes. So removal of moisture, volatile matter takes place. Here once removal of volatile matter, minus volatile matter takes place, right? So after again we need to weigh. Before that we need to cool. We need to cool crucible so that we can weigh easily. So next cooling, same cooling in desiccator. After this cooling, weighing. Let 4 be the double 4 be the weight of crucible with remaining coal. So here moisture is removed, volatile matter also is. Calculate volatile matter, just like same process, follow the same for calculations, right? So percentage of volatile matter is equal to double 3 minus double 4 into 100 by initial weight of coal taken. Initial at the beginning, initial weight of coal is 1 gram. 1 gram of coal. Right. Analysis. Any step. Weighing, keeping in furnace, heating, weighing, heating, cooling, and then at the end again determine the weight. Subtract removed volatile matter. You will know the volatile matter eliminated. Just to subtract double 4 from double 3. Next, calculate percentage. Right. So initially you need to consider initial weight coal taken. So last one in proximate analysis, ash. Simple, just continuance of previous one. Continuance of previous analysis. If you take fresh separate sample, again you have to remove volatile matter, moisture, unnecessary, just to minimize expenditure. We can save time also. So just to continue the previous one for analysis of ash. Simple, remove the cap, remove the lid. When you remove the lid, so after removing volatile matter, weight of bottle crucible is called double 4 grams. Right? After removing a lid or cap, it will make a difference. It makes difference. So that will also determine. Again, you need to determine weight. Next, weighing. Right? Let double 3 be the double 5 grams be the weight of bottle, weight of crucible with remaining coal. It does not contain moisture, volatile matter. And next, place it in furnace. Furnace. Right? Just heat it 740 degrees centigrade. 740 degrees Celsius. So total it undergoes complete combustion. Completely, it burns completely. After complete combustion, when it burns completely, the residue left in the crucible is called ash. After burning, residue left in the crucible is called ash. Determine the weight of the ash. Again, determine the weight of bottle crucible with ash residue left. Let double 6 grams. What is the weight? What will be the weight of ash? Double 6 minus double 5. Subtract double 6 from double 5. Weight of ash. Double 5 minus double 6. Percentage of ash. Percentage of ash is equal to, calculate same as you done previously, like this. Initial weight of coal taken 1 gram. Percent of ash is equal double 5 minus double 6 into 100. Initial weight of coal taken 1 gram. So last one, carbon. Proximate analysis, we can analyze moisture, volatile matter, ash. So carbon, just to subtract to percentage of total components from 1 gram of coal, you will know the carbon present in the coal. Percentage of carbon is equal to 100 minus sum of the percentage component analyzed. some of the percentage component. Initially analyzing what moisture plus percentage of volatile matter plus percentage of ash. These are the components we analyze. You will know the percentage of carbon. No need to analyze separately, right? Significance of proximate analysis. Significance. Proximate analysis. Proximate analysis. First component that we analyze impurity, that is impurity, is moisture. Presence of moisture is undesirable because higher the content of moisture, lower will be the effective caloric value. During process of combustion, if it contains moisture, it will get evaporates. For evaporation, it utilizes delta H, heat content liberated during combustion. Therefore, net calorific value or effective caloric value decreases. Presence of moisture undesirable. Presence of moisture undesirable. Next one, two. What are the component? Next component that we analyze is volatile matter. So volatile, even it during combustion, before involving combustion, it will get evaporated. It will escape as vapor. So presence of volatile matter also undesirable. Next, third one, ash. We know very well solid fuels having less caloric value. Delta H, amount liberated heat is called less. Comparing with liquid fuels. Liquid fuels after combustion, liberated heat content, caloric value less than the gas fuels. Solid fuels contain after combustion, they undergo partial combustion. After combustion, the residue left is as higher the content of residue, lower will be the effective value. And this useless, ash is useless, difficult to transport. We need to carry, we need to dispose. Therefore, presence of ash also undesirable. Ash undesirable. The last one, carbon. Higher the content of carbon in caloric value, higher will be the effective caloric value. So carbon is the main contributor. All fuels composed of hydrocarbons. Main chain consisting of only carbons. Backbone of all organic chains, carbon, made up of carbon only, undergoes combustion and main contributor in liberating heat energy. Therefore, higher the content of carbon, greater will be effective caloric value. So, presence of carbon is desirable. Right? Next, ultimate analysis. 2. Ultimate analysis. So, using this method, we can analyze carbon, hydrogen, sulfur, nitrogen, and oxygen. These are the components we analyze. First one, carbon, hydrogen. Very simple. Analysis of carbon and hydrogen. Very simple. We can do it in the laboratory. Just take 1 gram of coal in a closed container. 1 gram of coal in a closed container. This closed container attached to the bulbs. Bulb 1, bulb 2, 1 bulb, 2 bulb. Bulb 1, where this first bulb contains KO solution. Second bulb contains KOH solution. First bulb contains KOH. So before allowing to burn this coal, 1 gram of coal, determine the weight of first bulb. Let A1 be the weight of first bulb. Weight of first bulb, right? Weight of second bulb A2, A2, A1, A2, right? So when you after complete combustion, when you allow it to burn this coal, the supply oxygen, any combustion reaction in presence of oxygen takes place. Oxygen, you just to pass oxygen into the container, allow this coal to burn completely. After combustion, main products are, you know very well, main products are, what are the main products? CO2, H2O vapor and delta H. Here our purpose of analysis to know the hydrogens and carbons present in the coal, right? So combustion products are CO2, H2O vapor, H2O vapor. These are the two components. So when you pass these combustion products into the first bulb, where absorption of H2O takes place, absorption of H2O takes place. CO plus H2O vapor converts into CaOH2. Weight of the bulb increases because of absorption as calcium hydroxide. So determine the weight of the bulb. Let the weight of bulb after absorption, weight of bulb after absorption is called B1. Same process. Remaining combustion products contains only CO2. Pass this into this, where absorption of CO2 takes place. This second bulb contains KOH solution. This combines with CO2, converts into K2CO3. Again, weight of the bulb increases. How much of weight increased? Just to subtract, first to determine the weight of the bulb after absorption. Let weight of the bulb after absorption, weight of the bulb after absorption is B2. Let B2 be the weight of the bulb after absorption, CO2 after absorption. Why does it absorb? Because KOH combines with CO2 to convert this. So weight increases. How much weight increased? Just subtract this from this, this from this. So B1 minus A1 and B2 minus A2. So amount of H2O vapor formed and amount of CO2 formed. Amount of CO2. This is amount of H2O. So once you know the hydrogens, how many hydrogens are there? Using stoichiometric relationship, you can determine hydrogens and carbon present in 1 gram of coal. Initial weight taken for combustion only 1 gram, right? So only you are supplying oxygen. After complete combustion, these are the CO2, H2O vapors. Pass them into first bulb, second bulb. First bulb absorbs H2O as this and determine the weight. Increase in determine the weight. After absorption, weight is called B1. After absorption, weight of second bulb is called B2. Subtract this B1, B2 from bulb 1, bulb 2. You will know the amount of H2O vapor produced to amount of CO2. Using stoichiometric relationship, determine the hydrogen and carbon. Very easy. First one, I will explain this one, B1. So, 2 parts of hydrogen, 18 parts of combustion reaction are 2. H2 combines with half O2, uses to H2O vapor. Stoichiometric relationship, 2 grams produces 18 grams. But how much here produced after analysis? B1 minus A1, right? So write it in reverse direction so that you will understand which one is known, H2 or O2. Here after analysis you know the H2O only, not HS. Because of that you need to write reverse. 18 grams produced from 2 grams. So analyzed is called B1 minus A1. Produces how much? Is called B1 minus A1 into 2 by 18. And also calculate percentage. Percentage of hydrogen is equal to initial weight 1 gram of coal, you can write directly B1 minus A1 into 2 into 100 by initial weight of coal taken 1 gram, like that. This you can calculate same like this way, right? So your combustion first half reaction, your like here C converts into CO2 during combustion, right? C converts into CO2. 12 grams produces 44 grams. Among them, which one is known, which one is analyzed? CO2 is analyzed, not C. So you can write reverse direction. Like 44 grams produced from 12 grams. 12 grams. Here, how much you got? B2 minus A2 produced from how much? Right? From this B2 minus A2 into to 12 by 44. Also calculate percentage. Percentage of carbon is equal. Percentage of carbon is equal B2 minus A2 into 12 into 100 by initial weight of coal taken for analysis. How much coal is burnt for analysis? How much is coal for analysis? 1 gram. 1 gram is coal burnt. Like this. Next one. Analysis of nitrogen. Percentage of nitrogen. Just same. Take 1 gram of coal. 1 gram of coal in a closed container. Treat it with H2SO4. Dissolve in H2SO4. If any impurity like nitrogen is there, that will come out as NH3 gas, right? Treat this NH3 gas with excess HCl, excess known HCl, excess known strength, excess known strength. Let V1 be the value, V1 ml excess. Actually, we need to neutralize ammonia into ammonium chloride. Ammonia converts into ammonium chloride. Just we need about, let us assume 3 ml, but we have taken 10 ml, right? Excess known value, known strength, normality, known strength, right? After this, just to find out how much of HCl left. Here we are treating with excess HCl. Required suppose 10 ml. V1 instead of V1, here you have 10 ml. So need amount of impurity nitrogen present in 1 gram coal is very less. That converted into equivalent to ammonia gas after treating with H2SO4 solution. Just 2 to 3 ml is enough to neutralize ammonia as ammonium chloride. Find out remaining unused HCl. Just to treat it with, then treat it with NaOH solution or KOH solution. Right? So color, after adding indicator, since both are colorless, after adding indicator, color changes. Note down the titer value, reading. Titrate, not treat. Titration. With NaOH solution, after adding indicator, color changes. Note down the, when color changes, completion of reaction. What reaction? NaOH reacts with HCl. NaOH reacts with unused HCl, convert into NaCl plus HOH, right? So after this, note down the titer value. Let V be the titer value. So here indirectly you are going to estimate nitrogen. Whatever nitrogen is there, convert to ammonia chloride. That is equivalent to reacted with HCl. How much of HCl reacted with ammonia? Indirectly, in terms of HCl only. You are going to calculate in terms of HCl. That you will know, just subtract this V from V1. V1 minus VML. This much of acid reacted with reacted with ammonia. This ammonia, how do you get ammonia? How do you get this ammonia? Nitrogen present in coal, nitrogen. When you dissolve in HH4, it is converted to NH3. So whatever amount impurity in nitrogen is there, that converts to NH3, reacts with HCl. So you are estimating indirectly in terms of HCl, right? So volume of, in terms of HCl, I will write like this. Volume of, right, calculate percentage of nitrogen. Percentage of nitrogen is equal to V1 minus V ml into strength of acid used, strength of HCl into 14 nitrogen atomic weight into 100 by initial volume of coal taken for analysis, 1 gram. 1 gram, right? So now we analyze it this also. The last one, the last component in the coal, sulfur. So sulfur, the bomb kilometer, you better take in a closed container, as I explained earlier. Take again 1 gram of coal, 1 gram of coal. We can do it in the bomb kilometer also. Using bomb kilometer, we can determine calorific value of any solid fuel. So that bomb kilometer also closed container, detached with the surroundings. Neither products nor heat energy allowed to escape. After complete combustion, combustion will remain inside only. So closed container or bomb calorimeter. So completely detached, you will supply oxygen for complete combustion. In presence of oxygen only, any fuel burns easily. So after combustion, the combustion products are CO2, H2O vapor. If any impurities are there, like sulfur, sulfur also converts into sulfur dioxide, H2O vapor. High content of carbon, hydrogen. Solid fuels up to 1% of impurities like sulfur. Sulfur also combustible surface. After combustion, it combines with oxygen, get converted into sulfur dioxide, and it also contributes heat energy, but it's highly poisonous. Only one is disadvantage, sulfur dioxide. So after some time, when this closed system cooled to room temperature, this sulfur dioxide and H2 vapor combine each other, convert into H2SO3. Further, it converts into H2SO4, right? Treat this H2SO4 with barium sulfate, barium chloride. H2SO4 known barium chloride. So any impurity is there, sulfur in the form of liquid acid, that converts into barium sulfate. It will come out of the liquid solution in the form of precipitate and 2HCl, right? So PPT, solid is formed. Dry it, and then determine the weight, weighing. So let weight be the X grams, this barium sulfate sample. So using stoichiometric relationship, we can calculate percentage of sulfur. We also know the initial weight of coal taken, right? So barium sulfate, which one is known? We know the barium sulfate. You take actual gram molecular weight of barium sulfate is 233 grams. Barium sulfate contains how much of sulfur in these? 32 grams. Sulfur weight, molecular weight of sulfur. But after analysis, after burning, after combustion of 1 gram of coal, whatever sulfur dioxide released, that combines with H2O vapor inside. When it's cooled to room temperature, liquefaction takes place. How much liquefied acid is formed? That can be known by treating with barium chloride, BaCl2. So whatever the sulfur is there, that will get precipitated as barium sulfate. Using stoichiometric relationship, determine the weight, right? Amount dried precipitate weight, precipitate barium sulfate is X grams. contains how much. From this you will know the x into 32 by 233 weight of sulfur. Determine the sulfur, weight of sulfur. This is weight of sulfur. Then determine the percentage of sulfur. Same initial weight తీసుకొని coal, x into 32 by 233 into 100 by initial weight of coal taken, 1 gram of coal, right? Significance of proximate analysis. Significance of ultimate analysis. Already we discussed the significance of proximate analysis. This is significance of ultimate analysis. Right? First, what are the component we analyze it? First, carbon, hydrogen. So carbon is the main contributor. Presence of carbon is desirable. So as the hydrogen content increases, effective calorific value decreases. It should combine with oxygen and get converted into H2 vapor. So presence of carbon is desirable. Next component that we analyze in ultimate analysis is nitrogen. Nitrogen is non-combustible substance. In extreme conditions only it combines with oxygen. So it is non-combustible. Contribution is 0. Therefore presence is undesirable. Presence of carbon is desirable. Right? Third one that we analyzed in this method is sulfur. Combustible substance converted to sulfur dioxide, but is highly poison and contributes delta H also. Amount of heat liberated also it contributes some extent. But sulfur dioxide is highly dangerous. Therefore, presence of sulfur is undesirable. Right? Last, oxygen, fixed oxygen. So higher the content of oxygen, during combustion it combines with HS, converting to vapor. So for that conversion of oxygen, combination of oxygen and H, converting it into vapor, heat energy is required. From where it is getting heat energy? During the process of combustion, it utilizes that heat energy. Whatever amount liberated, that utilizes. So effective calorific value decreases. So 1% increase of oxygen, effective calorific value decreases by 1.7%. So presence of this also undesirable. Right? With this, I conclude. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.